Hi everyone, in today's lesson we're going to talk about how to verify trig equations, but before we can do that we need to review a few things first. The first thing is factoring with trig functions. Factoring with trig functions is exactly the same as factoring with regular variables. So let's look at this first one. Do you see how there's a cosine here and a cosine here? We actually can divide both pieces by a cosine x. So this cos x is my GCF. Remember, with a GCF, we throw it on the outside, followed by an open parenthesis. So cos divided by cos is 1. Cos divided by cos is 1, but I'm left with sine squared x. So if I remember correctly, this here is a trig identity. 1 minus sine squared is actually cosine squared. That can be multiplied with cos x. So then my final answer is just cos x times cos squared, which is cos to the third x. And that would be my final answer there. Okay, now example number 2, sine to the fourth x, or sine x to the fourth, minus cos x to the fourth, is actually the same kind of problem as if I were to do dots. So x to the fourth minus y to the fourth. That's actually the same thing as saying x squared and x squared, and then y squared and y squared, with a plus or minus in the middle. So we can do the same thing here. We're going to break this up into two open parentheses. Let's break up the sine to the fourth. So this would be sine squared x and sine squared x. And then we can break up cosine to the fourth as cos x, or cos squared x, and cos squared x, with a plus or a minus in the middle. Now, if you remember correctly, cosine squared plus sine squared is equal to 1. So this is 1 times sine squared x minus cosine squared x. And 1 times anything is just itself, so the final answer is sine squared x minus cosine squared x. That would be our final answer. Okay, now this third example is an example of how to factor trinomials. This is equivalent to saying 2x squared minus x minus 3. So you want to think of it that way. So it's 2x squared minus x minus 3. And the only way to factor something like that is to do guess and test. So we would break this up the same way. Except we would write 2 sine x and sine x instead of x and 2x. Now we want the factors of 3 that are going to add to a negative 1. So if we do some guess and testing, maybe we'll put a 1 here and a 3 here, and we'll test our outers and our inners. So the inners are sine x, the outers are 6 sine x. Now is there any way that I'm going to get a 6 sine x with a 1 sine x to add somehow to a negative 1? The answer is actually no, so maybe what we could do is switch it. So we'll put the 3 here instead. I just can't erase, so I'm just going to cross this off. So put a 3 here and a 1 here. So then my inners would be 3, and then my outers would be 2 times 1, which is 2. So now is there any way that I can get 3 sine x and 2 sine x to add to a negative 1 sine x? And yeah, if the 3 is negative and if the 1 is positive. That's it. That's my final answer. This here. Okay, now let's talk about something called working with conjugates. So you see here I have 2 minus x and 2 plus x. If I wanted to double distribute these, we start with the 2 times 2, that gives me 4. 2 times x is 2x, and 2 times negative x is negative 2x. Negative x times negative x is negative x squared. So these will cancel, and I'm just left with 4 minus x squared. Now, are 2 minus x and 2 plus x conjugates of each other? The answer is yes. Something that makes it a conjugate is if you just switch the middle sign, if it goes from positive to negative. So if this goes from positive to negative. Now let's see what happens here. We have 4x times 4x, which is 16x squared. 4x times negative 5. 5 times 4x. And 5 times negative 5 is negative 25. Well, look at that. The middle terms are canceling again. So 16x squared minus 25. So just by looking at these two things, do you notice that the conjugates, every time you multiply something with its conjugates, the middle terms cancel? So if I'm asking you to factor this or double distribute this, you don't even need to do the middle terms. If you know that it's a 1 minus sign and then a 1 plus sign, so if I'm switching the middle sign, we know that they're conjugates. So all we actually have to do is multiply the 1 times the 1, and then we don't even have to do this times this, because we know it's going to cancel with this times this. So we can just multiply these two, and we get negative sine squared x. And remember, if you remember your identities, 1 minus sine squared x is also cosine squared. So if you want to simplify it, that would be my final answer. Okay, let's move on to breaking up some fractions. So in order to get x plus 4 over 5, that comes from x over 5 plus 4 over 5. It's like you put the x over 5 and then the 4 over 5. That's all you have to do. This is basically saying if I were to make it one common denominator, we would do this plus this all over 5. So I'm going the reverse. So if I want to break this up into a single fraction, two single fractions, we would do this over this plus this over this. So let's write that. Sine x over cos x plus cos x over cos x. Okay, so now cos divided by cos is 1, and sine divided by cosine is actually tangent. So tangent x plus 1. And this is actually my final answer. Now, don't let this confuse you with one of those identities because it's not squared. Otherwise, we could make that cosecant. Okay, now let's try this last one. If I want to break up this fraction, this would be cosecant x over this whole thing, cosecant x secant x, plus secant x over cosecant x secant x. Now let's see what happens. These can cancel, and I'm left with 1 over secant x. These cancel, and I'm left with 1 over cosecant x. Now, 1 over secant is actually the same thing as saying cosine, and 1 over cosecant is the same thing as saying sine. These are the reciprocal identities, so cosine plus sine is the answer. Now, don't let this confuse you because they're not squared, so this does not equal 1. All right, now let's look at the last thing I want to review, finding common denominators. So if we look here, this is the general concept. There isn't a common denominator here. They're not the same. So we would need to multiply this side by x plus 3. And whatever I do to the bottom, I do to the top. And this side would need an x minus 3. That's how the process of a common denominator works. And then you distribute everything. So this would be what? 2x squared minus 6x. And we're going to distribute this. So 7x squared plus 21x all over the common denominator. And then you simplify anything you have on top here. So 7x squared and 2x squared is 9x squared. And then negative 6 plus 21 is 15 over x minus 3, x plus 3, and that would be sufficient for now. So the same concept applies when doing it with trig functions. So here we need a common denominator. So this side is going to need a 1 plus cos x, and this side is going to need a 1 minus cos x. So the common denominator would be this times this. So let's write that out. Maybe we could double distribute. It actually would be easier, I think, for us. So if we were to double distribute this common denominator, 1 times 1 is 1. Now, knowing this is a conjugate pair, you don't have to multiply this and this because you know they'll cancel. And this will just be this times this, which is a minus cosine squared x. And that's the denominator. Now, the top is just going to be this plus this. So let's write that. 1 minus cos x plus 1 plus cos x. Now, if we simplify the top, these will cancel, and I'll actually be left with 1 plus 1, which is 2. Now, 1 minus cosine squared is actually sine squared. Now, 1 over sine squared is actually cosecant, so this is actually 2 times cosecant squared x. It's a little weird to see, but this can actually be broken up as 2 times 1 over sine squared. That's where it comes from. So it's 2 times cosecant squared. Okay, let's see if we could try the last one. The last one is all about finding a common denominator again. So this bottom piece here has a sine x. It needs a cos x plus 1. Whatever you do to the bottom, you have to do to the top. Now this side over here needs a sine x. Whatever you do to the bottom, you have to do to the top. So if we distribute out this denominator, we can make one common denominator, which is sine x, cos x. So I just distribute here, and then plus sine x. Okay, let's see what we could get from this. And now the top, this is sine x times sine x, which is sine squared x. And now remembering, when I multiply cos x minus 1 and its conjugate, it's really the same thing as saying this times this, which is cosine squared. And then this here is negative 1 times 1, which is negative 1. So we should remember that sine squared plus cosine squared is equal to 1. So this is really 1, because this kind of goes away. So this is really saying 1 minus 1, which is 0. So 0 over anything, no matter what it is, sine x, cos x, plus sine x is actually 0. All right, let's move on to the next page. Okay, so now the whole point of this lesson is that we're going to use one or more of those different strategies we learned on the last page to help us verify trig equations. So what do I mean by verify trig equations? I really just mean that this left side of the equation has to equal the right side. But the general rule of thumb is that you're only allowed to simplify one side of the equal sign. So you can't manipulate both sides and you can't move across. You kind of like need to draw a line and basically simplify just one side until you get to the other. Okay, and these are the 5 methods that we just talked about. We talked about factoring, breaking up a single fraction, common denominators, and using the conjugate. The only thing we didn't talk about is writing the more complicated side using sine and cosine, which we can in this first example. So I'm going to do one of each, rewriting using sine or cosine. So if you look in this first one, we've got cosecant of x. We could write that as 1 over sine. And we know that cotangent of x is cos x over sine x. And we know that we're multiplying this by cos x. So let's figure out what this is first. We could put this over 1 and multiply the tops. So cos times cos is cos squared. And the bottom is sine x minus 1 over sine x. And it looks like I have a common denominator, so I can write it as 1 minus cosine squared x over sine squared. And isn't 1 minus cosine squared the same thing as saying sine squared? So this is sine squared x over sine x, which reduces to just sine x. So you see how now the left side equals the right side? And we're done. That is a proof. Okay, so just to reiterate, sine squared divided by sine x, that's the same thing as just saying, I'll write it over here, x squared divided by x. You basically are dividing them out, so 2 minus 1 is 1. Okay, so let's look and see if we can do another one. So I want to prove that this left side here equals the right side. So I'm going to draw a line, and I'm going to try with the more complicated side. And the more complicated side is obviously this one. And this is an example of how we could use factoring. So do you see how there's a sine x here and a sine x here? We're going to divide out the sine x. And what would we be left with? After we divide sine x here, we get 1. And after we divide sine x here, we get cosine squared. Now in order to finish this problem, you need to know that 1 minus cosine squared x is actually sine squared. And I want to multiply this by the sine x that's already here, and I'll actually get sine to the third x, which actually is this side. So, does the left side equal the right? Perfect. We're good to go. Okay, let's see if we could do another one. Sometimes it's more beneficial to break up a single fraction into two, like this case. So remember before, secant x over this minus this over this. So let's write it out. We've got secant x over secant x cosecant x minus cosecant x over secant x cosecant x. And I want to equal that where I want to see, so this is my line, if it equals this side. So we broke up this fraction into two fractions, and now we're going to simplify. So these cancel to 1, these cancel to 1. So it's 1 over cosecant x minus 1 over secant x. And we know that 1 over cosecant is actually sine x, and we know that 1 over secant is cosine. So, do I have sine x minus cosine x? Yep. So sine x equals cos x, and the left side equals the right, and we're good to go. Okay, so what I would like you to do on your own is see if you can answer this question. See if you can prove that the left side equals the right side using a common denominator. And we'll leave the next two pages, or I'm sorry, next two examples, these two, and we'll actually do those in class tomorrow. All right, so just do that one problem for me. All right, have a good night.